Hey guys, so this is problem 12 from chapter 9 from the section on phasors, and in this problem we have some kind of black box circuit. We know current is going in through that terminal, and voltage, and it's connected to an independent voltage source, and the voltage source is 300 cosine 5000 pi t plus 78 degrees volts. And the current is 6 sine 5000 pi t plus 123 amps. And we are looking for impedance, and we are also looking for how many microseconds that current lags voltage by. So, the first thing we have to do is to notice that current is expressed in terms of sine, and voltage is expressed in terms of cosine. And we can't compare cosines to sine. We have to give them a common ground. So what we're going to do is we can either convert voltage into sine or current into cosine. And the convention that the book has adopted is to work with cosine. So we're going to convert current into cosine. Now remember, cosine starts at the maximum and sine starts at midline. So basically there is a 90-degree shift. Don't forget your unit circle. Cosine and sine are off of each other by 90 degrees. So cosine leads sine by 90 degrees, so sine lags cosine by 90 degrees. So remember, I think it's easier to see here. Remember that cosine reaches the maximum and then sine. So at any point in time, so we extend here, and then we go back here. So cosine hits a maximum at time 0, and then it'll take 90 degrees more before sine will reach the same point if we're going forward in time. So that's why cosine will always hit the maximum before sine. So therefore cosine is sine minus 90. Sine is cosine minus 90 degrees. So if we shift cosine back in time, they will overlap. So this is going to be 6 cosine 5000 pi t. 123 minus 90 is 33 plus 33 degrees amps. So now we see that they are out of phase. So at 78, so cosine is shifted by 78 here, and then sine is the current is shifted by 33. So they are out of phase with each other. Voltage leads current by 45 degrees. So impedance in the phasor domain or the frequency domain is still the same. Z is equal to V over I. So so this is going to be, we're going to write this as phasors. And so voltage is 300 angle 78, and current is 6 angle 33. Put that into your calculator and you should come up with a value of 50 angle 45 is the impedance. So the impedance is 50 angle 45. Okay, so for part B, how do we find how much they're out of sync by? So let's graph this. Well, we're not going to exactly graph this, but so up here we have 300, and then if cosine had 0 phase, it would start at 78, right? So it would start at 0, the maximum would start at 0, but it's shifted by 78 degrees, so the maximum comes out here somewhere at 78 degrees. And looks something like that, and all the way down to minus 300, all the way down to minus 300. And then, so right behind that though, reaching its maximum at 33 is going to be, so here, somewhere at 33, we have current looking like that. Only going up to 6 plus and minus 6. So it hits its peak at that. Oh, well, actually, I just drew, yeah, that's right, cosine. So, like that. So here is this maximum, here is this maximum, somewhere at 33. And the question is, what is that time there? How much time is that? So, we know that it's 45 degrees. But how do we translate 45 degrees into a time? So let me just amplify this really quick. So we know that it's 45 degrees out. We need to somehow make the translation from degree into microseconds. So here's 33. So at 6, like that, and then like that. Oops, yeah, okay. And then here is 73, 78. So then at 300, we have this. And then we have this, and then, so we need to translate this into the time domain somehow. And that's going to come from the radians. Remember that radians omega is equal to 2 pi frequency, right? So if we do frequency is equal to omega over 2 pi, this will give us 5,000 pi divided by 2 pi, which is 2,500 hertz. So that means in 1 second we're going to see 2,500 of these cycles. So this will happen 2,500 times every 1 second. So that means one period, which is one maximum minimum, so one period like that, t is 1 over frequency. So when you do that, you will find that this is 0.4 milliseconds. So in 4/10 of a millisecond, you have one period. So this means a full rotation of 360 degrees. But we're looking for a time of 45 degrees. So in 360 degrees, we're looking for this time, right? So we have the period, one period, which is basically when it starts to repeat itself. One period, we now just figured out, is 4/10 of 1 milliseconds. So this is for one period, which is 0 to 4/10 of a millisecond. So how much is 1/4 of that? Because 1/4 of that is 45, right? Oh, actually, not 1/4 of that, but basically, this is also, we have 0.4 milliseconds per 360 degrees. But we are only interested in 45 degrees worth of that. So we're going to multiply this by 45 degrees to find out how much the difference is between the voltage and the current. So when you do 45 times 0.4 milliseconds per 360 seconds, which is one period, then that will give you 50 microseconds. So the answer to part B is 50 microseconds. And that's the answer to this problem. Don't forget to like the Facebook and share the video if you got help.